Performing a little experiment here. I'm testing the heat loss through various glazing materials. See which one performs better. So in this thick walled styrofoam container, that's a 25 ohm resistor with 7.1 volts across it. So that's about 2 watts of dissipation inside this chamber. And I position that so it's right in the center. And over here I have a probe for a thermometer. Over here is the thermometer that measures the temperature outside of the container and inside. So there will be heat loss through the walls of the container, plus heat loss through the material that I set on top here. So right now I have a window sash. It's low E coated. I found this at the Restore for $8. So I figured it would be a good thing to test with. It's brand new, low E coated, and had the film and everything on it. So I don't know why somebody turned it in there. Maybe it was the wrong size or something. But anyhow, what I want to do is try different materials and check the heat loss. See what the delta T, in other words the difference in temperature between the inside and the outside of the chamber here is. Okay, here are the results in a spreadsheet. So first one is with the lid on, and that's this cover here. Styrofoam, so it's going to have very good insulative properties. And as you can see, it shows a delta T of 23.4 degrees. This is all in Fahrenheit, by the way. I had to measure the outside temperature on each test because it takes about an hour to let the temperature stabilize, and going through the day the temperature heats up in the house. I turned the air conditioner off so the cold air wouldn't blow across the outside probe and throw it off. But anyhow, a single pane glass, see it dropped way down to 12. Single piece of acrylic is 12.4, so it's slightly better. Here's where it really jumps up. Standard double pane glass jumped up to 15, and the low E coated double pane glass jumps up to 19.1. Pretty impressive. Wasn't expecting that much of a increase. I was figuring maybe 17, but 19.1. Pretty impressive. And I left the lid off, or I left the chamber open, I should say, just to see what the difference would be. Stabilized out at 3.4. That's because the heat source and the probe are kind of close together, and there might be a little bit of warmth even with the chamber open. So you can imagine if the temperature outside in winter was, say, like 20 degrees and the indoor temperature was 70, that's quite a bit of difference. That would allow a lot of heat to radiate through the window glass outside, causing quite a bit of heat loss. Whereas with the low E coating, which would reflect the radiant heat back in, you would lose quite a bit less heat that way. Of course, that depends on the surface area of all the windows in your house compared to how well your house is insulated and all that good stuff. So there you go. Pretty interesting test. And if you're getting new windows for your home, I would certainly consider getting the low E type. Well, that's it. Thanks for watching.